talking about renewable and non-renewable resources. And really in particular, we're talking about fossil fuel formation. All right, so make sure your notes are out and let's get to it. The very first thing we have to do is talk about the definition of a renewable and a non-renewable resource. This is something you know, it's something you've been talking about since you were little. All right, a renewable resource is one that gets replenished, something that comes back. And we do add a little time frame on there, 100 years, or about one human lifespan. So one human lifespan just means that if we plant a tree on the day that you're born, by the day that you die, we could chop down that tree and use it as a resource. We could build a house with it or something. A non-renewable resource then is a resource that takes much, much longer than one human lifespan to collect, accumulate, or be produced. And again, the most primary example that we have is fossil fuels. And that's what we're going to talk about next. A fossil fuel is just simply a molecule, okay, made out of hydrogen and carbon. We call it a hydrocarbon. And the reason we have so many different types of fossil fuels is because these hydrocarbons, they make chains. They all link together into these big long chains, and when you break the bonds that make up that chain, it releases energy, and that's what combustion engines run on, and that's why fossil fuels are used all over the world for a whole bunch of different things, okay? The different lengths of chains have different names, things like gasoline and kerosene and propane and butane, and all of those different fuel types and names just represent a different length of hydrocarbon chain. Now we're going to look at how our common fossil fuels are formed. And the three most important fossil fuels that humans use are coal, petroleum, and natural gas. So taking a closer look at coal formation, the really important fact you have to know about coal is that it forms in a bog. Okay, a bog or a swamp or a marsh or a wetland, all of those types of areas really define the same environment, one where there's standing water. So what happens is trees, plant material, die and fall into the water, and they get buried in sediment over time. And then through lots of pressure and heat and chemical reactions, everything that's not a hydrocarbon is squeezed from that plant material, leaving behind the hydrogen and carbon, and that's the hydrocarbon. This process is called carbonization, where we're removing everything that's pretty much not carbon from that material. And there's 4 steps in carbonization. The first one is peat. Peat is partially decayed organic material like the plants we were just talking about. From there, we have lignite. Okay, and lignite is actually burnable coal. It's a usable source of energy, although it's not as efficient, it doesn't produce as much energy as coal. The third step is going to be bituminous coal, and that's a fun word to say, bituminous coal. And again, what's happening here, just over time, more heat and pressure is just removing even more materials that just aren't hydrogen and carbon from the coal. And the very last step is coal or anthracite. Anthracite is kind of like the scientific rock name for coal, and coal's just a more common name for it. And anthracite, after this big long process of carbonization, has the highest amount of hydrogen and carbon, the most densely packed hydrocarbons, and that's why it can produce the most energy through burning. We're actually going to talk about petroleum or oil and natural gas formation together, because oftentimes they form the same way. They actually can be found together in the same rock layers. And what happens here is we have, again, organisms dying millions of years ago. And those organisms have to be protected from oxidation or just rotting and decay, and also protected from scavengers. So it's very important that these dead organisms get buried by sediment and water very rapidly. Again, there's lots of heat and pressure, lots of chemical reactions involved that squeeze out hydrocarbons from those organic remains. Okay, so unlike carbonization, which removes everything that's not a carbon, hydrocarbon, with petroleum and natural gas, what we're doing is we are squeezing out the hydrocarbons from those original organisms. And that material, that oil and natural gas, then moves up towards the surface. And it would come right up to the surface of Earth if it wasn't for what we call the cap rock. The cap rock is impermeable, meaning that the gas, the oil, cannot travel through it. So since it can't travel through that rock layer, it starts to be collected and accumulates, again, over long, long periods of time. Where this natural gas and oil is collected is called the reservoir rock. And when we drill down into this reservoir rock through the permeable cap rock, a lot of times the first thing that geologists find is natural gas. And then they keep drilling, they keep moving down, they'll find the petroleum. And that's just a separation based on densities, gas and liquid. Make sure that you get a good diagram of what we call an oil trap in your notes. The last two fossil fuels we're going to talk about are tar sands and oil shales. And you may not have heard about these, but they're going to be important, let's say maybe at the end of your lifetime or your kid's lifetime, because they're just not very efficient methods of extracting fossil fuels from the ground. Okay? There are going to be alternative areas to find petroleum, to find fossil fuels, instead of just drilling straight into the ground. So a tar sand is a combination of sand and a petroleum material. Okay, that makes it the tar that is in the name. And it's very thick and sticky and it can't be pumped out of the ground. So it needs to be strip mined. So removed from the surface one layer at a time. From there, they need to separate out what they want from what they don't want. We don't need the sand, we want the tar, we want the fossil fuel. So using superheated water, really hot water, okay, they soften that tar, releasing the sand to be deposited. And now you have hot water and oil, and you know oil and water don't mix. The oil goes to the surface where it can be removed and then refined into gasoline and all of the other products that we use fossil fuels for. Oil shales are a very similar idea to tar sands, but instead of being that kind of sandy, tar, waxy mixture, this is actually just a rock layer. So it's fossil fuels trapped in a shale rock layer, and they need to be mined just like any rock is mined out of the earth. And then from there, you can extract the fossil fuels. But both of these methods, the tar sands or the oil shales, just really aren't cost effective at this point. It's much easier just to go out and find, an oil trap and drill down into it and pump out oil. But someday in the future, we're not going to be able to poke holes in the surface and extract oil anymore. But we still have this massive infrastructure of our entire planet running on fossil fuels. So we're still going to need fossil fuels, and we just won't be able to find them easily. So tar sands and oil shales will help to supplement, they'll still be feeding us fossil fuels that we need to run our planet the way it is. That's going to wrap up everything you need to know about fossil fuels and fossil fuel formation. Make sure if you have questions, please make sure to ask. Thanks.